Hello again, and welcome to a new lecture in which we will examine couples in 3 dimensions. So if you remember, a couple is a moment produced by two forces that are parallel and opposite and have equal magnitudes. So in this case, we can consider such a couple in 3 dimensions. So one force is negative F and the other force is plus F, and in order to determine the moment produced by this couple of forces about an arbitrary point, say point O, all we have to do is sum the moments produced by each force. So position vector RA cross F plus position vector RB cross negative F, where these position vectors start from the point O, point above which we sum the moments, to any point along the lines of action of negative F and F. So this expression could be also written as RA minus RB cross F. Now what is RA minus RB? Well, it's the same thing as RA plus negative RB, and we can then construct the parallelogram to find out the result, and it turns out that RA minus RB is this vector in purple, which is also identical or similar to another vector that runs from negative F to positive F. So this would be, let's call it R. So therefore the moment of the couple equals to R cross F. Now we can express this cross product again through a determinant ijk, rx, ry, rz, fx, fy, fz. And now, given that the original position vectors ra and rb were going from O to any point along the lines of action of negative f and f, the new vector r will also go from any point along negative f and any point along positive f. So again, r, very importantly, goes from any point along negative f to any point along positive f. So what I've shown on the diagram also is the resulting moment, MO, and using the right-hand rule, one can see that these forces in this case would rotate counterclockwise, so the positive direction of MO is obviously going up. Now, as before, vector MO is always perpendicular to both forces, F and negative F. So it will be perpendicular to the plane that contains these two forces. So again, as you can see, couples in 3D are expressed in the same way as the moment about a point, and the result does not depend on the location of the point about which we sum the moments, which was point O. So let's do an example quickly in which we have a shaft, which is the one colored in purple along the x-axis, and there are two levers connected rigidly to the shaft. So they are both parallel to the y-axis, and let's put some dimensions. So each of these levers is 250 millimeters long, and also the distance between the levers measured along the x-axis is 150 millimeters. And also at the end of the levers there are two forces having a magnitude of 100 newtons each. They are both parallel to the z-axis. One acts in the negative direction of z and the other one acts in the positive direction of z. The question asks to express the couple of the forces in Cartesian vector format. So in other words, we need to calculate the moment and express that determinant. But first of all, we need to decide which one is plus F and which one is negative F. And if you look carefully in this diagram, the force on the left points upwards, so it's parallel to the positive direction of the z-axis, and hence we can consider this one as being positive F. The one on the right goes towards the negative direction of z, so this will be negative F. We also need to determine now the position vector that goes from negative F to positive F, and we can select it as shown. And R can be expressed from the given dimensions as negative 150 millimeters times I plus negative 250 minus negative 250 millimeters J plus 0k millimeters. If you rearrange these terms, this will give us negative 0.15 I minus 0.5 J in meters this time. The forces are parallel to the z-axis, so we can express them as 150 k newtons. Therefore, the moment of the couple is equal to the determinant ijk, and then the components of r, negative 0.15 and negative 0.5 and 0, and then the components of the force 0, 0, 150. And if we express this determinant, I'm just going to jump over a few steps and just give you the final answer. That would be negative 75 I plus 22.5 J Newton meters. So as you can see, the moment does not have a z component, which is what you would expect, because in this way the moment vector will be perpendicular to the plane contained by both forces. So that's about it for couples in 3 dimensions. Thank you very much for watching this lecture, and I will see you at the next one.